Welcome back, dear students, to the tetrahedron chemistry classes. So in the qualitative analysis series, today I am going to solve the problem number 3. Okay, and these problems are very important for the IIT JEE examination. Sometimes very important for your GATE and your IIT exam examination. And this is the usual curriculum of any BSc chemistry students or the MSc students. So you need to understand such kind of how to solve such kind of the problem. So first of all, I'll read the question. I will read the question completely. I will convert it into the flow chart. So if you want, then you can skip directly this language of the question and straight up jump to the flow chart, which I have done just after 1 minute after reading this particular question. But for the beginners, I am going to read this question. Okay, your compound A is a light green crystalline solid. It gives the following test. Okay, it dissolves in the dilute sulfuric acid. No gas is produced. A drop of the potassium permanganate is added to the solution. The pink color of the KMnO4 disappears. Compound A, when heated strongly, gives the gas B and C with very pungent smell, and a brown residue is also left behind. And next, number 4 is the gas mixture B and C, when passed into the dichromate solution, the solution turns green. And next, number 5, the green solution from the step 4 gives a white precipitate E with a solution of the barium nitrate. And in the last observation, residue D from the step 3, that means this particular step, this residue D, right, uh, is heated on the charcoal in the reducing flame. It gives a magnetic substance. So it's a quite clear indicative that your compound is giving the magnetic substance. It may be the salt of your iron, right? This is the first impression which you can get from this last point. Okay, and then you need to identify all A, B, C, D compound, right? I have converted this into the flow chart. This is your compound A, right? And this compound A, the physical property is what? It is light green crystalline solid. So this is a very good indication or very good observation, physical state by which you can narrowing the margins of the different kinds of the salts in identifying the exact structure. Okay, so first of all, you need to know which salts are light green crystalline solid. When I'm saying it, they are the crystalline solid, that means water of hydrations are there in the molecule. So if I move further, see, this is your Mohr salt, which is light green in color, and this is the ferrous sulfate solution, which is again a light green but not that light like your ferrous ammonium sulfate. Third is the nickel sulfate, which is a very dark green, and this is your nickel chloride, and this is again you can see the very bright green. So based on the observations, light green colored, your compound may be either your Mohr salt or your ferrous sulfate. You can discard this nickel sulfate as it is very dark, and you can discard the possibility of the nickel chloride as it is very bright in color. And one more very important thing you should note, that this nickel sulfate, when you heat it around 800 degrees centigrade, then it can produce your sulfur trioxide gas. Similarly, your nickel chloride, when you heat it somewhere around at 700 to 750 degrees centigrade, it will produce yellow color gas, which is your chlorine gas. But this yellow color gas observation is not given in the question, so you can discard immediately this possibility again on the second observation, which is not there in the question, which is your the release of the chlorine gas. And uh, however, your pungent smell gas like sulfur dioxide and sulfur trioxide, they are actually produced by the nickel sulfate. Not they are, but only the your sulfur trioxide can be produced by this one. Okay, but it will happen at very high temperature, which generally we will not use in the qualitative analysis. So based on this, we can discard the possibility of the nickel and the nickel sulfate and the nickel chloride. So you left with the Mohr salt and your ferrous sulfate. So for this, you need to know the what is the formula of the. But again, the very important observation is that if you heat this particular compound, ferrous ammonium sulfate, at very high temperature, which is given in the question, it will also release the ammonia gas. And ammonia gas is having a very characteristic smell, which is not given in the question itself. So you can discard the possibility of the Mohr salt as well. But you left with this ferrous sulfate. Your compound may be the ferrous sulfate, and definitely it will be present in the hydrated form. So 7 of water molecule would be there. So from the initial examinations of the compound, like the color and the gases which the compound will release on the strong heating, where we can say the ferrous sulfate heptahydrate may be your possible compound. But let's check what are the other options given in the questions. And one very important thing is that you need to identify the color of the compound as well. That's why I have given the color of the compounds here. So what was the first observation? First observation here, my compound is looking like ferrous sulfate heptahydrate. And very important thing which is given here, the magnetic substance is formed. Magnetic substance basically is the substance which is nothing but the iron. Okay, so if you see the first one and the last one, then you will find, okay, your this ferrous sulfate heptahydrate could be the answer, because uh, this will produce iron, and that iron is magnetic in nature. Okay, so we are getting closer to the answer. And then what will happen in the second observation, you see, if I when you dissolve this light green color compound in the dilute sulfuric acid, no gas is produced. This is a typical behavior of your sulfates, because your iron sulfate will never produce any gas when you dissolve this into the dilute sulfuric acid, right? No gas is produced, because dilute sulfuric acid is used to check the hydrolysis of these salts. This strongly recommends the compound A as the ferrous sulfate compound. Okay, to this particular solution, if you add the potassium permanganate, a drop of the potassium permanganate, this pink color of potassium permanganate disappears. This is something very important, right? So what we can conclude, this is a very famous reaction. You are having this ferrous sulfate solution, and you have added sulfuric acid to it, which is your H2SO4. Okay, and then you are adding KMNO4. So what reaction will happen? It will form your ferrous or ferric sulfate, FeSO4 whole thrice, plus manganese sulfate, MnSO4, plus potassium sulfate, K2SO4, and your water molecule. Okay, here you can see your iron is in +2 oxidation state, and this is your ferric sulfate, so iron is in +3 oxidation state. Your manganese here is in +2 oxidation state, and here your manganese is in +6 oxidation state. This is something very important you need to understand. Not +6, actually it is +7. +7 oxidation state. Okay, so what is happening here, you can see this iron is undergoing oxidation. Iron is undergoing oxidation, and you know the species which undergoes oxidation in the redox reaction, they act as the reducing agent. They act as reducing agent. Okay, and you know this these ferrous ions are very classic reducing agents. And in the next step, you can see this is your manganese. Okay, and this manganese is going from +7 to +2. That means decrease in the oxidation number. So this process is basically your reduction. That means it will act as the oxidizing agent. I am writing OA for this one. Okay, so what will happen when you add little of KMNO4 to this particular solution, these ferrous ions will quickly reduces this Mn7 positive to Mn2 positive. That means this pink color, you know, KMNO4 is pink in color, it will the pink color will disappear, because this compound will form. This is a very important reaction in the class 12th as well. This reaction is very important in the what happens when your iron sulfate reacts with the potassium permanganate in the acidic medium. Okay, and for the beginners, if you want to balance this particular reaction, so your 2 of KMNO4 will require, because 2 MnSO4 I have formed already, and sulfuric acid, your 8 of sulfuric acid will require, and 10 of ferrous sulfate will require from here. 2 MnSO4, then 8 H2O will form here. So this is the first part of the question. Light green solution, when dissolved, light green solution of your compound A, when added camphor to it, the pink color disappears. So this is how the things are going. Okay, this is something very, very important. And then what you can see here in the next step, compound A, when heated strongly, it will produces two things, gas B and C, and the brown residue FeSO4, say dot 7H2O. This is hydrated form. Okay, if you heat it very strongly in the lab, say somewhere around 200 degrees centigrade, okay, so what will happen? Earlier this was light green crystalline due to the presence of these 7 water molecule. Now it will become white powder. If you heat it strongly as given in the question, this is basically your, say, gas B, and this is your gas C, and this compound, which is nothing but residue, brown residue, this is rust. And now you are having the two gases, and out of these two gases you can see this sulfur dioxide can act as a reducing agent. I am writing Ra for this one. Why it will act as a reducing agent? Because it is having only two oxygen, it may convert into the SO3, right? When it will undergo to the form, when it will undergo oxidation, it will form the SO3. That means the sulfur get oxidized, and the things which are oxidized act as the reducing agent. So this is a reducing gas. This SO2 is a reducing gas. Observation is given here. Pungent smell observed. So this pungent smell is basically due to the sulfur dioxide and sulfur trioxide, and moreover this sulfur trioxide basically comes into the air. Its fumes goes into the air. This will gives your say pungent smell. Okay, but this is a non-reducing gas. Please remember, because it cannot be sulfur trioxide cannot be oxidized further. When it cannot be oxidized further, it cannot act as the reducing gas. But this SO2 is a very good reducing gas. So this is the residue, this is gas, this is gas. Okay, so now you have identified your A, B and C and D as well. Okay, now what is happening here? These gases B and C, that means sulfur trioxide and sulfur dioxide, when passes into the dichromate solution, dichromate, you know, potassium dichromate. Potassium dichromate is your K2Cr2O7 solution, and the color of this solution is orange. Please remember, the color of this solution is the orange. And when you pass this sulfur dioxide to it, or sulfur trioxide to it, okay, only sulfur dioxide will react because it is a reducing gas, and your medium will be acidic, H2SO4. Again, this is a very famous reaction. So what will happen? Your potassium sulfate will form, K2SO4, and your chromium sulfate, Cr2SO4 whole thrice, it will form along with the water. Okay, so it is given here, when you pass this gases B and C to this solution, the solution becomes green. So this solution basically is green solution. Earlier it was your orange. So why it is green? Green is due to the formation of this chromium sulfate. Green solution. If you do this particular reaction in the lab, then you will find really when you do this reaction, your solution becomes green. So this green color is due to the formation of their chromium sulfate. And what will say, after to this green particular solution, when you add the barium nitrate to it, then your last compound E is formed, which is your white precipitate. Okay, so to this chromium sulfate, so I'm writing your another reaction. This was your Cr2SO4 whole thrice. You are reacting it with barium nitrate. Barium nitrate is your BaNO3 whole twice. Then what will happen? What is happening in the reaction? Your white precipitate is forming, and you know, very famous white color compound in the qualitative analysis is what? Barium sulfate. So your barium sulfate will be precipitated out from here, which will be your white color precipitate, and your chromium nitrate whole thrice. Okay, this will form. So what is happening here? This barium nitrate is basically forming the barium sulfate, which is your white precipitate. So now you have identified all. A, B, C, D, and E. Okay. If you want to balance this particular reaction, so what will happen? You need 3 of the barium sulfate and sorry, barium nitrate, and 3 of the barium sulfate will form, and 2 of chromium nitrate will form. Okay. So this is how the reaction will go. This is something very, very important. Okay. So nothing is happening to the chromium here. Earlier one, it was in +3 oxidation state here, and again it is in +3 oxidation state. So this reaction where there is no redox reaction is taking place, this reaction is basically a double displacement reaction. This last reaction is the double displacement reaction. Okay. Double displacement reaction means your salts are exchanging ions, nothing else. Okay. So there is no problem up to this point. So what I can do, you can take the snapshot of this one, because I am removing this thing from here, because I need to go for the last step. This brown residue, which is D actually, when heated strongly, when okay, heated on charcoal in a reducing flame. See, this brown residue D, when heated on the charcoal in a reducing flame, it forms a magnetic substance. So how we can form the magnetic substance? For this, you need to understand the reaction. Your D was your iron oxide, Fe2O3, right? And you are heating it with you are heating it in charcoal. Okay. In a reducing flame. Please remember, in a reducing flame. So what will happen? The reduction will take place, and here your iron is in +3 oxidation state, and when it will reduce it will go to this particular elemental form, and your 3 of the carbon monoxide will release from here. So this is your magnetic substance. So I am writing MS for this one. This is your magnetic substance, and this is your charcoal, and it is undergoing reduction. Okay. So this is how you can solve such kind of the problem. So you see, initially if you look the problem, it looks quite difficult. If you go thoroughly to this through this particular problem, then initial observation, which is the light green crystalline solid, will reduces the probability of your answers, right? So this is what I have already done in this case, but this is not that over simple, which I have explained to you. You need to understand many things for this one. Okay. I hope you understood the things. If you understood the things, please like the lecture and subscribe the tetrahedron chemistry classes if you're watching video for the first times, and do share with your friends as well. I'll meet you in the next class. Okay. Thank you very much.